Grant Skinner.
Well, here we go. So hello, I am very happy to be here. It's I keep hearing about this wonderful conference, FFK, and kept wanting to come talk at it. And as Mark said, he's invited me a couple of times, and the timing's just never worked out. And so I finally made it. So I'm very excited. Of course, it's not FFK anymore, though. But I'm not talking about Flash anymore, so it kind of fits. So before I launch into my talk, I want to tell you just a little bit about myself, just so that you have the context of what I'm talking about. I'm Grant Skinner. I run a shop called gskinner.com. Over the last 10 or so years, we've done a ton of interactive development, almost primarily with Flash. I've traveled around the world, spoken at conferences like this about Flash for most of that decade, and I've become known as hopefully at least an adequate Flash developer. About a year and a half ago, I was approached by Microsoft, and Microsoft said, "Hey, we know all about the stuff that you guys do with Flash. We'd love to see what you can do with HTML5. We're rolling out IE9 in a few months. We'd love to prove that it's possible to build a real casual game on top of HTML5 running in IE9." And we were pretty hesitant about it. I mean, we'd been working with Flash for a long time. We were really familiar with the technology. And honestly, our few experience with JavaScript and HTML wasn't very good. I mean, we really struggled with cross-browser issues and stuff like that. But we figured, hey, if Microsoft's going to pay us a bunch of money to learn this stuff, why not? We'll give it a go, right? So we spent a few months on it, and we wound up building this game called Pirates Love Daisies. And it's a pretty straightforward tower defense game. You place your guys, and dudes come in, and they try and steal your daisies and take them back to the water. Nothing super amazing and new, especially for the Flash world, but this was really one of the first HTML5 games that showed that you could build a real game inside of HTML5, not just little demoware pieces. And so we were pretty happy with this, and Microsoft was really happy with it. And as we worked on this game, we also started working on some frameworks that would help us build these types of experiences going forward. And so what I'm here to talk to you about today is HTML5. Big umbrella term, but looking at different pieces of it, some of the work that we've been doing with it, especially some of the work that we've been doing to facilitate other people's work, so stuff that lets other people create cool content. And as we go, a little bit of discussion around some of the problems that we've run into and how we've solved them. This talk was originally 90 minutes. That's what I gave it Toronto, and today it's 45 minutes, so I'm going to talk really fast, hopefully. So when I started doing HTML5, being kind of a community figure, I started to run into some resistance. So I got some lovely comments like this. "You jumping in HTML5 world, supporting Apple, void words, and showing to many of your followers new direction. If Flash will die someday, you are going to be responsible for this even more than Steve Jobs. My heat is bleeding." So my point isn't, to make fun of Devu for his articulate argument. It's and in fact, I actually kind of respect this guy's passion for his technology. I just think that the way he's expressing it is misplaced. I think, being defensive around a technology is wrong. We aren't defined by a technology. We're defined by what we can do with those technologies, what we can create with those technologies. I mean, artists don't define themselves by their tools generally, right? An artist isn't an HP pencilist, right? They're an artist. I'm not a Flash developer. I've spent the last 15 years of my life being an interactive developer, maybe a web developer, but just because most of that time was based around a single technology doesn't mean that I'm specifically a Flash developer. And I think that this is important for us to think about. Another example, this one a little bit less on the crazy spectrum. The piece of this that really stood out to me is this bit about jumping ship, right? That I'm jumping ship from technology. And I don't really understand this. To me, technologies are not ships, they're not religions, they're tools, right? I don't have to choose to be on one technology. I can choose to have many technologies and pull those out of my toolkit as I need them. In fact, my company continues to do lots of Flash work, right? I personally am not doing a lot of Flash work anymore, but that's because my role in the company is largely around R&D. I'm trying to spearhead the direction that my company is going in, and my company is good at writing Flash code. We don't really need anyone doing R&D on that anymore, so I've been spending a lot of my time on Flash. So I'm not trying to convert anyone here to HTML5. That's not my goal. I just want to introduce you to something I've been playing with and having fun creating new things in. So why would you want to be interested in HTML5? So I'm kind of going to position this a little bit from a Flash developer's perspective, but I think there's kind of 4 core reasons right now. I think the first is reach. And short term, this is pretty much around iOS, right? Working in HTML5 lets us build some pretty rich content that can be viewed on iOS. And obviously, we can't really do that on Flash, at least not in a web deployable fashion. I think long term, though, this is more compelling. I asked myself this question a few days ago. If I look at new technology platforms coming out, new devices, new operating systems, and I ask myself, is Flash going to live there? Is Flash going to be supported there? Today, the answer is a resounding maybe. I don't know. But for those same platforms, if I ask myself, are they going to try and build the best possible HTML5 web standards browser they can? It's absolutely. I mean, every vendor right now, this is their focus, is having the best HTML browser. And so it gives me a lot more certainty that I can deploy my content to anyone. I think there's a ton of opportunity here, and I think particularly for people with experience in interactive. The traditional web world doesn't have a lot of experience in building interactive content, working with transitions, working with stateless applications, working with asynchronous operations, where a user clicks something, stuff happens, and then we have to resume once something finishes. If you look at the content that's being shown as demos for where HTML5 is going, you look at things like Beauty of the Web or a lot of the stuff on the Google Chrome store, a ton of the top demos are being done by Flash developers. I mean, Brandon Hall, my company, Ricardo, Mr. Doob with Tween Jas, all of these guys have their pedigree in the Flash world. I actually mixed up my bullet points there. That was experience. That's how your experience applies to the opportunity. There's a okay, so that was experience. Let's go back to opportunity. Obviously, there's a lot of opportunity there. It's a big buzzword. Clients are willing to fund it right now, whereas they're still uncertain about Flash, right? I mean, I think there's some more money going back into Flash nowadays, but people love throwing money at HTML5 right now, and that's not a bad thing. Finally, there's a lot of challenge in this space, and it's actually part of the reason that I'm liking it. For me, about 2 years ago, I was kind of in a funk. I was kind of getting bored of the Flash world, and it's not because you couldn't create really cool content, but it was because it was becoming so mature and so predictable that there just weren't a lot of problems to solve anymore, right? It just kind of worked the way it was supposed to work, and building cool projects, sort of, right? Building cool projects just sort of became a matter of budget instead of a matter of really deep creativity and trying to work around technical hurdles. And to be honest, HTML5 is kind of a mess right now. I mean, and to me, that's kind of cool. It's kind of fun. So with that said, HTML5 is not for the faint of heart. There's still, browser inconsistencies that we have to work around. There's still major performance gaps. There's constant barrage of new specs and APIs coming out, some of which are supported on one platform, some of which are inconsistently supported across multiple platforms. But I'm having a ton of fun with it. And some of this stuff is getting better, right? Inconsistencies are starting to smooth out. There's always some new ones introduced with every browser build. Performance is getting a ton better. If you look at Canvas performance specifically, which is what a lot of my focus is on, if we look at Safari 5.0 versus 5.1, Safari 5.1 got hardware support for Canvas, and we had like a 5 to 6x increase in performance. More importantly, looking at iOS, we went from about, so this benchmark is based on the number of sprites I can move around on screen. It's sort of simulating a game environment. And in iOS 4, which didn't have hardware acceleration, we had like 40 sprites was the maximum, which you really can't do much at all with. Whereas with iOS 5, we're up to like 2,000. So that's like a 50x increase in performance between those two versions. As a more concrete example, we built this demo about a year and a half ago on iOS 4, and this represented the absolute pinnacle of what we could do with iOS 4 performance on the canvas. And it took just about every trick we could come up with to make this thing run as well as it does. Today, that game Pirates Love Daisies that I showed you at the beginning, which was specifically built to tax desktop browsers, to push them to their limits, runs on an iOS device, on an iPad too. So that's pretty incredible to me. Things are changing so quickly in this space. As I said, APIs are constantly coming out. I mean, this is just a few of the ones that I'm keeping my eyes on. Oops, kind of jumped through that, but it doesn't really matter. There's hundreds of specs that are always coming out, and it's really hard to keep up with what is happening. So you have to kind of choose the ones that you're interested in and follow along with them and try and determine when they're ready for use. But this is also kind of fun. It gives you stuff to play with all the time. Google approached us to build a demo using web audio, WebGL, WebSockets, basically any API that started with web. And we threw in some CSS3 and a ton of JavaScript. And I'm just going to show this to you really briefly because I don't have much time. But so basically what we wound up building, and this is inspired by Andre Michel's Tone Matrix, is this multi-user music creation tool where you can basically throw down some beats and have up to 5 people playing with you in your band. I'm not a musician, so I'm not even going to try. And you can kind of work together to create a music piece. You can invite your friends in, you can go into solo mode, and people have been building some kind of cool stuff with it. So, this is just... Or if you're more into drawing than you are into music, what does Mario sound like? Not very good. Or this one kind of impressed me in its extreme simplicity. And so basically this lets you create this music and you can layer on all kinds of different effects like reverb and convolution and stuff like that. And this is all enabled on top of web audio and WebSockets. And you guys can play around with it. So that I don't have to spend time on it right now. Safari loves doing that. So, as we've been building these things, let me rephrase this. One of the things that I realized a few years ago about myself is that I love creating things. It's something that has defined my career. But one of the things I love even more is I love creating things that other people can use to create things. I love sharing code. I love building tools. I do tons of this. And so as we've been working on these commercial projects, we've been using them as a way to sort of fund development of open source and tools that we can then provide to the community so that they can build cool stuff as well. And it's been great working with companies like Microsoft and Google because that's what they're all about. They're really excited to have us go out and do this stuff. And so I want to spend some time showing you guys some of the stuff that we've been working on that you guys can play with to build your own cool content. So I want to start out with some JavaScript libraries we've been building out. So we've released Create.js, which is at createjs.com. Right now it's a suite of 4 libraries and 1 tool. 4 libraries are Easel.js, Tween Jas, Sound.js, and Preload.js. I'll go into them in more detail in just a second. But basically, you can use them individually or together to build sort of Flash-like experiences on top of the HTML5 stack. And this is built on top of 4 core philosophies. One is that it's approachable, so we've tried to have pretty good documentation, a really straightforward API, leveraging existing knowledge around things like Flash developer knowledge, trying to emulate some of the things that Flash can do. We want it to be modular. So I specifically did not want to create one of these monolithic JavaScript libraries where you take the whole thing and you're stuck with it. I wanted to make it so that each of these libraries can be used individually if they do just the one thing that you need them to do, or you can use them together to get, to create a larger project. I also, within the libraries, wanted to make it so that they were very modular. So there's a lot of pieces inside of these libraries that you can pull out individually and just use, the single class that addresses the needs that you have. They have to be extensible. We wanted these to be very general purpose. I didn't want to build, for example, a specific game engine that just builds one type of game. What I wanted to do is build a framework that anyone could then build game engines on or could build data visualization systems on. And finally, I wanted it to be totally open. So these are all MIT licensed, which means you can do pretty much anything you want with them. And they're all living on GitHub, and we have a thriving community on top of this right now. So let's look at them individually. So Easel.js is our graphics layer. Right now, it mainly targets Canvas. It provides you with a display list, a mouse interaction model, and a bunch of helper classes. A lot of these classes will look pretty familiar if you have a Flash background, right? We have display object and shape and bitmap animation, text, container, which aggregates display objects together, and then our stage, which lives at the root of every Canvas display. We have some helper classes. We have a ticker, which is like the heartbeat of your whole application. But again, we want this to be modular and extensible, so you don't need to use our ticker. You can use whatever heartbeat you want. Ticker's just there so you can get started easily. Some geom stuff. We actually have a whole filter model. And we have things like movie clip, which is sort of more specific to tooling, and I'll talk about that later on. So let's take a really quick look at a little bit of code. I don't want to, hit you guys with a lot of code, but I want to show how easy this is to get into. So I can create a new stage pointed at a canvas. That's what it's going to draw to. Create a star, which is a shape, begin a fill, draw a star into it, set an X, Y, and add it to my stage. I'm also going to add a daisy, which is a bitmap, so it's just pointing at an image. I have a little shortcut that lets me set transform, so this is positioning it and scaling it to 200% and changing its alpha. And then last, I'm going to add a text field and same kind of thing. I'm just going to put it on stage. If I run this, nothing shows up yet. Reason being that you have full control over when the stage actually renders. So you can tell it to render, and if you don't tell it to render, nothing's going to show up. So we actually have to tell the stage to update. Okay, so all my stuff shows up. What about animation? So I can go, so to do animation, obviously I need a heartbeat, so I can listen to my ticker, and I can just say, add this as a listener, and all I do is define a function called tick. And this function is going to get called every heartbeat, and all I'll do is I'll say star.rotation plus equals 3. Now if I run, and I'm going to want to update my stage also, because otherwise it's not going to redraw. Now if I run this, my star is now animated. Nice thing about this is I can also make this time-based, so it's going to pass in the time between the last tick and the current tick, so I can make all my animations based on the time. So now it's a function of that delta, same kind of animation, but now if I change my FPS, so let's say 20, so it's going at that speed, 100, a little bit smoother, but exactly the same speed because it's time-based. But what about animation? What if I want to use something like a Sprite Sheet? Well, obviously we support that. You can basically create a Sprite Sheet, tell it what images are going to be part of this Sprite Sheet, so we support multi-image Sprite Sheets. We can either go with simple or complex frame definitions. In this case, I'm just saying all of my frames are the same size, you figure out where they are. And I can define animation sequences. So I'm saying From frame 0 to 3 inclusive is my run animation, and when it finishes, I want you to play the run animation again. So I just want you to loop. From 4 to 10 inclusive is my explode animation, and when you're done, I want you to go back to run. Then I'm creating a pig instance, or a pig, which is an instance of bitmap animation using that sprite sheet, putting it on the stage and telling it to play run. So this is what my sprite sheet looks like, and here's my lovely space pig running in space. But I want this guy to explode when I click on him, so let's wire that up. So all I do is say pig.onClick equals function, and I'm just going to say this dot go to and play explode. And let's try that out. Boom! A bacon explosion. So, but that's kind of fast, right? It's running a little too fast. It's not really easy to see what's going on. So I can change the timing on this. So I'm going to say only advance his walk animation every second frame, and I want the explosion to be crazy dramatic. So I'm going to advance it every 8 frames. And if I run that now, you can see that he's walking a little bit slower. And if I click on him, we have this super dramatic explosion. But I also want, this is a space pig, right? So I want him to moonwalk. So I'm going to also add the equivalent of an enter frame handler. I'm going to say function equals this.x plus equals 3, right? Very familiar if you do Flash work. And boom, now I have a moonwalking pig. And he still explodes. All right. Last thing I want to talk about with Easel.js is interaction, because of course interaction is really important. We looked at onClick, but we have basically all of the mouse interactions that you would expect. So we have onPress, we have on mouse over, on mouse out. We deal with things like dragging a little bit differently. Propagating a move event is really expensive through a display list because it happens a lot. We have to go through the entire display list to tell everyone that something's moved. So what we do instead of slowing everything down is we pass you an event object in onPress that actually has its own event handlers for on-mouse move and on-mouse up, and that exists for the duration of that press. So once it's released, that event stops being, or that event object stops having its handlers activated, but during that press, during that drag, it remains active. So you can see here, when I press the daisy, it gets this event object, and then I listen to that event object's on-mouse move and on-mouse up. And I don't need to unsubscribe from that handler at all because it just drops it as soon as it's released. The kind of neat thing I'm going to show you really quickly is something called stage auto clear. So I'm going to, I'm going to say, when I first press this, I'm going to stop clearing the stage. When I move, I'm going to change my Daisy's rotation a little bit. And when I release, I'll turn back on auto clear. Okay, and if I run this now, drag this around, it starts painting, right? It's okay, this is kind of neat. It's good for like generative art and that kind of thing. It's something that you could do in Flash, but had to do a lot of like manual work to get there. But what's more important is that we don't want to be isolated. We want to be a really friendly library that you can use with whatever you want. And so, for example, one of our clients was building a game, and they used Impact.js, which is a really great game development library. But it's kind of a control freak. It wants to own the heartbeat. It wants to own stage refresh or canvas refreshes, all that type of stuff. And the nice thing is that all they had to do for Easel.js to work with it is turn off auto clear and use their heartbeat with Create.js, and it worked perfectly fine because that way we're not clearing off the stuff that Impact draws. So we can coexist really well with a lot of these other libraries. And this kind of ties into something that I think is really important around building these types of experiences. There are a lot of different layers in HTML, right? We have the DOM, we have SVG, we have Canvas, we have WebGL, and we're not limited to just building stuff on one of them. We can really leverage the strengths of all of these different surfaces. And I think that's something really fantastic. And so we've tried to make it easy for you to do this within the context of the library. So one of the things that we do is we have this class called DOM element that actually lets you point to an element inside of your HTML DOM and have it controlled inside of the easel.js display list. So you can move it around using X and Y and alpha. You can actually stick it into a container and it'll deal with the aggregate transformations. So for example, in this case, I have this piggy container and I'm putting the pig animation into it, but I'm also putting this DOM element, this pointer to a speech bubble, into that same container on my display list, and then I can just move the piggy around and everything comes with it. So this speech bubble, this is just HTML, right? HTML is great at displaying text, and it's also nice because it extends past the boundaries of my canvas, right? And it means that I can take advantage of all the things that HTML does well. So I can actually have links and stuff like this. And all of this would require a lot of manual work. There's one in here that's really freaky. This thing. What the heck is that? I don't know. But it means that we can leverage the strengths of this environment really effectively, but still have it contained inside of easel.js. I want to show you a real-world example here. So this is actually another game that we built with Microsoft. And it's kind of interesting in that the game engine itself is all built inside of Canvas, right? All the tanks, the sand, all of that stuff, because Canvas is great at displaying that type of thing. The UI around it is all using jQuery and HTML, because that's the stuff that HTML does great, right? Interactive elements, text inputs, all of that kind of stuff. HTML is great for it. And then for these pieces that need to sort of merge between the two environments, these like health bubbles, those are using DOM element. And that way we can keep them synced with all the things that are going on inside of our game engine, but we can still use HTML text, we can use CSS, and it's really easy for us to control the style of those things. We have a whole filter model. I'm not going to go into a lot of detail on it because we could go pretty deep. But basically, you can write filters. They can either live inside the display list and you can assign them to display objects, or you can use them completely independently. You don't need to use any of the rest of easel.js. You can actually just point a filter object at a canvas, tell it what area to affect, and it'll paint the filter there. So again, this is the sort of modularity of these libraries. The next library I'd like to talk about is Tween Jas. So this is our animation library. And this is actually a lot of fun for me to write. I've written a lot of surprisingly painful, large number of tweening engines over the years. And it was kind of fun to come into JavaScript and try and write one that was specifically for JavaScript and really embraced a lot of the ethos of what JavaScript is. So it has a very, very simple API. It's like 4 methods on it or something like that. It doesn't have any events, nothing like that. But you can do really incredible things with those methods, all through sort of sequencing. So really simple example to start out with. Just going to throw a ball on stage, put on a label, give it a little bit of text, and create this simple tween that's just going to a Y position over 2 seconds with a bounce out ease, right? And that gives us this nice little bounce. But then I can add all kinds of stuff to it. So Tween Jas supports non-numeric properties, so it'll set a non-numeric property at the end of its tween, and it lets me actually target other objects in a tween. So in this case, from this tween targeting the ball, I'm going to say, do the bounce, then change the text on the label, wait for a second, then I want you to change the text to fade, alpha down to 0 over the course of 1 second, change the text to done, wait another half a second, and then call the alert function on window with the parameters all done. And so if I run this, right? So no events or anything. Instead, you just put calls in whenever you would want an event out. So really simple. This is like the core of the API. There's some other stuff, but This is mainly what does it. But what if I want tweens that are targeting different objects to actually affect each other? So let's say I want this label to fade in first, and then I want the whole rest of this animation to come in. That's pretty easy too. Let's start out with our label faded out. 0. I'm going to want a reference to this tween. And I'm also going to want it to start out paused. So I'm just going to say, when you create yourself, you're going to start out paused. And then all I do is I create a new tween for my label. And I'm going to say alpha up, so alpha to 1 over the course of a couple seconds. And when you're all done alphaing in, I want you to actually go back and then play the rest of this stuff. So fade in, and the rest of the animation starts up. So a really easy way to sequence these things together. So this supports a lot of stuff out of the box. It supports, sync timelines. So we actually have a timeline object that you can add a bunch of tweens to keep them synchronized with each other and affect them as a group. Obviously, easing, sequencing, non-numeric props. It's completely deterministic, which I think is critical in a tweening engine. So basically, if you say go to, 0.67 seconds, it will always look exactly the same at that point in time. You can always jump to any point in time and know that it's going to reflect perfectly, even if you've been moving things around in the meantime. Overriding, so you can assign you can create a tween on a target, and then you can create another tween on that target and decide whether or not they should run parallel or whether one of them should override the other one. And finally, and I think really importantly, it supports plugins. So we wanted to keep this tween library really tiny. It's like 3K or something like that. And as part of that, I didn't want to have to teach it what CSS was, because CSS is a pain to tween, because everything is a string property. You have to deal with appending pixels onto things. It's kind of a mess to work with from a tweening perspective. So instead, we wrote about a 1K plugin, which handles anything CSS-based, right? So the core library doesn't need to know these things. So this is just a really simple example. But the key point here is that this stuff is all, I don't know if I can select it, but this is all just divs in the DOM, and it's all being animated by Tween Jas. And all I had to do was turn on the CSS plugin, and it knows how to deal with this stuff. More importantly, though, you can write your own plugin, so you can get it to do all kinds of stuff it was never initially built to do. So we have graphics, we have animation, we want sound. And sound is one of the biggest messes on the web today. Sound is really hard to work with. There's a bunch of new proposed APIs coming out, like web audio, which will hopefully address these issues. But right now, sound is really difficult to work with. There's all kinds of undocumented problems with it. API is really limited. And so what we wanted to do is we wanted to build a library that abstracted a lot of that from you so that you could just work with a single API, know that it's going to work, and really importantly, we wanted to make it pluggable so that as things like web audio come out, you don't need to rewrite any code. You can just say, okay, now use web audio, and away it goes. A lot of people are using Flash still, which I find kind of ironic, to do all their audio for HTML5 games. And so we have a Flash plugin. So you can basically say things like this. You can say, I want you to favor using the HTML5 audio tag. If you can't do that, use the Flash plugin, register those plugins with it. It will choose which one is best for the environment that you're on. You can pull it for capabilities, so you can say, based on the plugin that you're using, do you support things like panning? And it'll say yes or no. It obviously has a lot of global properties, so you can set global volume and stop all sounds and stuff like that. And when you play sounds, it'll pass you back a sound instance so that, for example, you can work with individual sounds and change their volume, change their panning, find out when they're complete, those types of things. And the whole API is based around a principle of failing silently. So, panning doesn't work in HTML audio. We don't start throwing errors if you try and pan. We just don't do it, because that's not a critical failure, right? If your game doesn't have panning working, and you actually told us that we could use HTML audio, we don't want to take down your game just because we can't pan the audio. Likewise, audio just doesn't work on iOS. There's huge limitations on iOS, and so we basically just say, oh, you're on iOS? Nothing. We don't, again, throw errors or anything. We just say, yep, nothing's going to work. You can call us all you want. You're just not going to get audio. Which is a lot better than our initial attempts at this, where the game would just kind of crash and destroy itself, or would take like minutes and minutes to load as we waited for each audio element to error out. So I'm not going to spend much time on this, but just to give you an idea, we can play some audio. That'll create an audio instance. I can work with the volume on this instance individually. And we have interesting features like sound overriding. So I've said I don't want more than 3 channels of thunder running at any point in time. So you should override the oldest one when I tell you to play the 4th one. And this is important for HTML audio because HTML audio has huge limits on how many audio elements we can actually instantiate and use at any time. So this lets you prioritize your audio. So we kind of have the pieces that we need to build an experience, but we need to load all the stuff in. And this seems like it should be pretty easy. In the HTML world, it is not. So we built Preload.js. And Preload.js basically will try and use a new API called XML HTTP request level 2, or XHR2, which lets us load in media assets and actually get things like progress events. Because when we're doing tag loading, which is how you traditionally bring assets in, no progress events. So if we have XHR2, we give you real progress, and we give you aggregate, and we give you an aggregate of that process. So you can load in 100 things, and we'll tell you what the aggregate of all that progress is. If not, we'll automatically fall back to tag loading. We'll still give you progress, but it's going to be a little bit more jumpy because it's going to be based on completion. And this is instantiable, so you can create a whole bunch of queues and have them running together. You can actually put queues into other queues, so a queue can manage a queue of queues. And this is kind of how it works, right? So I create a queue, I listen to see when it's done, I can listen for the aggregate process or progress on it, and then I can load a bunch of stuff in. And this is kind of the simplest format, and it'll manage bringing in those images and data and scripts for me. We have some sort of more advanced features in it. So again, we have support for plugins. And so Sound.js, if Sound.js sees Preload.js when it initializes, it'll actually add itself as a plugin to Preload.js. And that enables a few things. One of them is that you don't need to manually register your sounds back with Sound.js as they load. Sound.js will just handle that itself. The other thing is that we can define which assets to load. So for example, if we're on Firefox, we need to load OGG files. Pretty much everywhere else we want to load MP3s. So Sound.js can actually have that logic inside of it instead of Preload needing to know anything about audio. Sound.js can also tell Preload that if it's on iOS, just don't bother. Don't bother loading anything. Or if we're using Flash in Sound.js, it can actually channel the progress of the sounds loading in Flash back to Preload so that Preload still gets progress and can display it correctly. We can also get the results of everything that we've loaded, so we can get access to the images and sounds and stuff like that, which means that not only can this queue act as a load handler, but it can also act as like a centralized media repository, which can come in really handy some of the time. So again, all of these are free, all of them are released, and they're all up at createjs.com. So that kind of covers the developer side of things, right? So you can write code and build these projects, but to me, that's only half the equation, right? To get really great content, you need to get designers involved, and you want to make it really easy for them to participate in this process and see things in real time the way that they're going to look when things are developed. So we've done a few things. One of them is we worked a little bit with Adobe on their Sprite Sheet export tool. And so one of the output formats in the new Flash Pro CS6 is actually Easel.js. And so you can generate out sprite sheets, and it'll also, alongside it, generate a JS file that includes easel.js classes that extend bitmap animation. So you don't need to write that code. You can just suck them in, instantiate them, and they even do kind of weird things like add methods on, which I'm not sure I really like. So you can actually say, my dog.run, and it'll go to and play the run animation. So kind of neat. Before this stuff happened, we also built our own similar tool that takes existing Swift files and reads their labels out, spits out all their animation into a sprite sheet. And it's fairly similar. It has less of an integrated workflow, but it still has a few features that can make it useful once in a while. For example, we support multi-image sprite sheets. So if you have a lot of assets that you want to, or a really long animation, we'll actually break that into multiple images. This is really critical on mobile because you have fairly limited image sizes that you can work with. We also do smart frame reuse. So CS6 will do what they call image stacking. So if there are identical images, they'll reuse it. We actually have a threshold value for this. So you can actually drag this reuse frames slider, and you can tell it how much different images have to be to not be reused. And so we'll say, oh, well, these are pretty similar. We're just going to reuse it. And we can bring down the file size of your sprite sheet quite a bit by reusing images. The thing I'm most excited to talk to you guys about, though, has been my baby for the last few months, which is Toolkit for Create.js. And this is also a project I've been working with Adobe on. And basically, this is a tool for publishing assets out of Flash Pro that you can then bring into Create.js projects and write projects around. So what does this do? Well, in version 1, we're supporting bitmaps, text, vector art, a couple of filters. We actually support the add blend mode and, of course, normal blend mode. We respect the caches bitmap flag inside of the UI. We have our own caching mechanism inside of easel.js. We understand groups. We understand movie clips. We understand graphics. We only support classic tweens. We don't do shape tweens or the new motion tweens. And we also understand labels, sounds, and I'll show you this in a second, but you can actually do some scripting on the timeline and have it exported correctly. I've highlighted warnings because this is version 1. There's absolutely a lot of stuff that we don't support right now, so we make sure that we let you know when we're going to break. That's a critical feature in a 1.0 project, I think. So let me show you a quick example of this. So this is a little robot animation that my illustrator put together. If we come in and look at the robot, we have some labels, we have some timeline animations, we have this vector bubble. All the robot graphics are bitmaps. We have some sound on the timeline. And then at the very end here, we also have some actions. So we have this special breakout comment. It's a comment block starting with JS. This tells the panel that we want this to be injected into the JavaScript timeline. What we're going to do is go to and stop hello, change the text on the speech bubble, and add this onClick handler onto this, right, onto the robot. And when I click it, we'll throw an alert, and then go to and play start. So this is now running inside of HTML5 on top of Create.js. And you can see the animations all working. The audio fired, robot does the robot, and code executes. We're back on this frame. We've changed the text, and if I click this guy, alert fires, and we restart. Right? We've spent a lot of time working on the workflow for this as well. Oh, damn you, Safari. So basically what we say is the designer owns the FLA completely. They own the preview HTML that we generate, and then they pass the JavaScript library that's generated off to the developer through version control or just manually, and then the developer can completely own the game logic and their deployment HTML. And so what that winds up looking like in real life is this. So I have this platypus game that my illustrator has quickly sketched out. And basically, I have some assets in a library. We've agreed on some names for those assets. He's going to publish this out. Looks like that. He'll throw it over to me. I'll come in. I'll write a little bit of code around this. So for example, here's where I'm actually adding platypuses to the stage, right? So new library.platypus. This was exported. And I can build all of this logic. Is that time right, or is my time right? That time is right? I think you shorted me. I have a timer right on this thing. All right, well, I'm going to try and go. Can I have like 5 minutes? All right. So I can build this whole game around these sketch assets. And, oops, I'm really bad at it on a trackpad. And get this whole thing working. And at the same time, my designer can be working on new graphics. So I'm just going to cheat, and I am going to change some layers, because you guys do not want to see me draw. And so then he can just publish this out, refresh that. This is my completed assets now. He can hand this over to me. I haven't changed any of my code. All I'm doing is bringing in the new library that's just been generated. And boom, I have this full working game, right? Haven't changed anything. My names have stayed the same. So this is kind of similar to like working with Swix and Flash Builder, if you've ever used that workflow. Worth noting, this diagram was actually all exported using Publish as well. Of course, you can do the whole timeline thing. I don't really recommend it, but I do think it's kind of neat that it works. So this is an example. There's no external code, just about 35 lines of JavaScript inside of the FLA. So I'll show you that. So this is 31 lines of JavaScript here, and I can publish this and fully playable game, right? Okay. Code is totally human readable. This has been super important to me. I've stressed over every single line break and every single space in it. You can actually read this code, which is very different from a lot of the existing solutions. I've also spent a ton of time on file size. So these are all animations by Chris Georginas. If we look at the Swift size for this first one, the Swift is 37 kilobytes. Zip compressed, which is how most servers will send JavaScript assets, 9K for the JavaScript library that's generated. In this case, all assets are vector, so the JavaScript library is the only asset it generates. This does not include the framework, which on its own is about 27K for all 4 libraries zip compressed. But to partially address this, we are doing CDN hosting on the libraries. So the libraries will be cached across any sites that use them. And Adobe is providing this. Devices, yes. Hells yes. So this is, hopefully you guys can see that. I'm bad at this. There we go. Exact same game, no changes, running on iOS. It's important to stress that this is not an exporter. You're not just going to take old content, push a button, and have it running. This is a new workflow. This is designed to let you create great content, writing your own JavaScript, but letting you create these assets easily. And of course, it's only 1.0. So we are going to be working with Adobe over the next year or so. We're going to try and do quarterly releases of this because we know there's going to be problems. We know there's features missing. And we know that the web is going to change, so we're going to keep updating this. This is not bound to the usual year and a half release cycle of Flash. I'll show you this really fast before Mark drags me off the stage. So this is entirely experimental right now, but we figured, right now we're rendering to canvas. What if you want to do WebGL, say? This is now WebGL. What if you want to do the DOM instead? You're on an older device, and the DOM is hardware accelerated and Canvas isn't. This is the DOM. These are just images that I can drag off, et cetera, et cetera. With SVG, we have a not very well-working Flash version of it as well. We also thought, can we put this on the server? A lot of people are using Node.js, including us. We thought maybe it would be neat to be able to do programmatic graphics on the server. And it was pretty easy. We got this working really quickly. So you can actually use easel.js on the server to generate assets. So for example, if you have interactive data visualization on the client and you run into a browser that doesn't support it, you could always generate a static version of that and send the image up to the client. You can take a picture of this if you want. These are the resources I found really useful. The top one is the most important by far. If you're doing JavaScript work, anything you search for, tag MDN onto it. Mozilla Developer Network, it's actually contributed to by both the Chrome team and the Firefox team, and it is by far the best JavaScript API reference you can find. Can I use lets you know whether or not features are available, what the propagation levels are, and if you're a total masochist, the w3.org site, of course, has the real specs, which are a pain to go through. So that wraps me up. A little late, but and thank you very much.